Okay, hi boys. This video here is supposed to help you understand the proof that the root of 2 is irrational. So a question may come up this way, which is prove that the square root of 2 is irrational. Okay, and we're going to prove this by contradicting ourselves, so it's known as a proof by contradiction. Okay, so what we start off with in the proof, right, and just so we're clear, this is the proof. We must say that we let the root of 2 be rational. Okay, so we let it be possible to express it as a fraction, a over b. Okay, so we are imagining this scenario that we could put it as a over b, and then we're later in the proof down here, we're going to be able to contradict that after we've done a little bit of development on that. So we let the root of 2 is equal to a over b in its simplest form. And what we mean by simplest form is that neither a nor b have a common factor. So a and b have no common factor. There is no way to tidy that up. Okay, so that's the first thing we do. So I'm going to put in s here for simplest form. Then I'm going to put in another s to help you, which is to square both sides. Okay, so these little letters, if you learn those off afterwards, they'll help you to remember what to do with the proof. So of course we're going to square both sides, and we square the root 2, we get 2. We square a over b, then we're going to get a squared over b squared. And just so you're sure on that, I'll just do this on the side for a second. A over b to b squared is equal to a over b multiplied by a over b. And fractions are top by top and bottom by bottom, so of course we get a squared over the b squared. Okay, so that's why I got this result here. Okay, right, okay, so let's move this on. Now what we do is we multiply the b across, or basically multiply both sides by b squared. Okay, so we get 2b squared is equal to a squared. Okay, now so that implies that a is divisible by 2. Okay, because this must be an even number, and if it's an even number, and it's a square, say like 16, then the square root of that would be 4, and that was divisible by 2. Okay, so it just so happens that this is a feature. Okay, a is divisible by 2 if a squared is divisible by 2. Okay, right, so I'm going to go SS2 as our little key there, so that we know that SS2, the 2 stands for divisible by 2. Okay, now then we let a equal to 2k, because if it's divisible by 2, it's equal to 2 times another number. Okay, so that gives me 2b squared must now be equal to 2k 2b squared. And now I square again. So we square this out again, and we get 2b squared is equal to 4k squared. And I'm going to put in t now for tidy. So I can tidy this up a bit by dividing by 2. So I get b squared is equal to 2k squared. Okay, what does this tell me? Well, in the same way when I had the a squared was twice something, now I've got b squared is twice something. So b must be now divisible by 2. But this is what's key. If a was divisible by 2, and if b is divisible by 2, well then this was never in its simplest form. So we have now contradicted ourselves. Contradiction. Okay, I'd like you to be able to write that down. Okay, so I'm going to put it in here as part of this, write that it's the contradiction. Okay, so we have now a contradiction, and because of that contradiction, we can say that the root of 2 is not equal to a over b. Okay, now this is typically a 10 to 15 mark question, and if you do it exactly like that, you will get the 10 to 15 marks. Okay, and the reason why I've put this SS2 STC is that it can be helpful just to learn that. So if you learn SS2 STC, all right, it can help you to remember how to do the proof. SS2 STC. Okay, all right. Have a look through that, and if there's any problems, we'll be going through it again anyway in class. Thank you.